So my own curiosity in terms of science and the universe is I have like I've seen a new theory that the universe is conscious and everything around us has a level of conscientiousness to it. And that might explain this double slit experiment. I'm just curious if you've explored, I'm sure you have, thinking about the universe and our existence.
Oh, sure. I've written hundreds, perhaps even thousands by now, of pages about this and yacked about this for gazillions of hours. Yes. I mean, the whole question about sort of intelligence, consciousness, these kinds of concepts, lots of things are that way. They're just not that way the way that we humans are. In the end, our brains are physical constructs that have a bunch of electrical signals going around in them. Something like the weather is something that consists of a bunch of pieces of air and water vapor and so on, kind of moving around according to certain rules, just as the neurons in our brains operate according to certain rules. So in some sense, there's the same kind of level of computational sophistication of what's going on in the weather, what's going on in our brains. There's a thing I call the principle of computational equivalence, which kind of captures this idea. And then, but the issue is, to what extent are those things aligned with the human view of the world? The human view of the world has evolved over the course of time that humans have been around, but there's sort of a characterization. I talk about it as points in rulal space, that different minds, different things that one might think of as mind-like kind of exist at different places in rulal space. And so two human minds might be pretty close together. Human mind relative to your average dog or something is a bit further away. Relative to the weather, it's considerably further away. Relative to the whole universe, it's also far away. But absolutely, the universe and the principle of computational equivalence, which we have, well, rather, it's kind of interesting because I invented this idea back in the beginning of the 90s. And it's something where at first it seems like, really, can this possibly be true? But now there's sort of a generation of scientists who are younger, who kind of grew up knowing it. And for them, it's sort of obvious that it's true. It's kind of obvious to me that it's true too. But it's kind of interesting to see how that progresses over time. But kind of the idea that there's this computational equivalence between lots of things in the universe, including the whole universe itself, is something that is, I think, pretty clearly understood at this point. Now, in terms of the relationship between that and things like quantum mechanics and the double slit experiment, that's a whole big technical stack of stuff. But, to say one thing about that, okay, so quantum mechanics is kind of the theory of how small things, little tiny things in the universe work. And its main feature is, when we think about ordinary classical physics, we think that definite things happen. I don't know, roll a ball, it's going to roll in a definite direction. In quantum mechanics, what it says is there are many paths that it could take. And we only get to know things about the probabilities for different collections of paths. So there's kind of these many different paths of history that get explored. And that's the big story of quantum mechanics, is many paths of history get explored. So now the question is, why do we think definite things happen? If there are all these paths of history that are being explored, why is it that we humans think definite things happen? Well, I mentioned before, one of the features that we have is we believe we're persistent in time. We have the single thread of consciousness. We believe that definite things happen. But in a sense, we are part of this universe that is branching through all these different kind of paths of history and so on. That's what's happening in our minds. So it's kind of like the story of how does a mind that is going through all these different branches of history perceive a universe that is also going through all these different branches of history. And the thing that is kind of the story of quantum mechanics is kind of how that fits together. And, well, for example, one of the mysteries in the double slit experiment is you've got these two slits, and you have photons that can go through one slit or the other. And, you look at some screen behind these slits and you say, did a photon arrive in the middle? Well, a photon could go through one slit just fine. It could go through the other slit just fine, but you'll never find a photon in the middle. There's destructive interference between kind of the waves that correspond to these photons. But it's kind of weird that you would think with classical physics, if it can go through one side or it can go through the other side, well, it's got to by the time it could go through either side to get to this place in the middle, it's got to be there in this place in the middle. It turns out that in our understanding now of how quantum mechanics works in our models, it's well, what seems to happen is that the photon is kind of in this collection of branches of different branches of history. They're kind of laid out in what we call branchial space. And effectively what's happening is going through each different slit corresponds to going to a different end of branchial space, a different place in branchial space. And when we humans, with our attempt to kind of make the universe fit together, when we say, can we make it all fit together? Because these photons kind of went to different ends of branchial space, that there's no way to make them fit together like that. And so we say, well, there isn't a photon there. I mean, there's a big depth of technical stuff, which I've just elided in that description, but it's kind of that's maybe some flavor of how one starts to think about things like that.